Hello and welcome back to my channel. Today in this video we are going to discuss the last 5 questions from May-June 2021 Pure Mathematics 3 9709. The component is 3-1, that is from question number 6 to 10, and we have already discussed the first 5 questions in the previous video, so let's discuss the last 5. And here is the question number 5. Is question number 6. The parametric equations of a curve are x equals ln 2 plus 3t and y equals t over 2 plus 3t. A part is to show that the gradient of the curve is always positive. Gradient of the curve means dy over dx. So we know dy over dx we can write it's a dy over dt and dx by dt. So we technically require dy over dt and dx over dt. Why? Because we have this parametric equation, means y in terms of t and x as a function of t, we can say. So we can differentiate y and x with respect to t. So dy over dx, here it is a upon b, u upon v, we can say, and there it's a quotient. So we are going to use this quotient rule for differentiation, and that is denominator square and plus denominator, and then numerator, it's a denominator in the numerator we multiply by denominator, and it's differentiation, numerator's differentiation of numerator minus numerator as it is and differentiation of denominator, that is 2 plus 3t, and that would be 3. And we can see if we multiply 3t minus 3t would be cancelled, and finally we get dy over dt as 2 over 2 plus 3t whole square. And since x equals ln 2 plus 3t, so dx by dt become 1 upon 2 plus 3t and multiplied, because we are going to use a chain rule here, so multiply by the differentiation of 2 plus 3t. So finally we got dx over dt as 3 over 2 plus 3t. And we'll substitute this value here to get the gradient of the curve dy over dx. We got dy over dt over dx over dt. Finally we got 2 over 3 times 2 plus 3t. Now we have seen that x is ln 2 plus 3t, means, and we know the input for the ln cannot be negative, so it has to be greater than 0. It means 2 plus 3t is always going to be greater than 0, and here 2 and 3 are already positive numbers, so it means dy over dx, that is the gradient of the curve, is always going to be greater than 0, and that's what we need to prove. For the b part, find the equation of the tangent to the curve at the point where it intersects the y-axis. So from the first part we have seen dy over dx is 2 over 3 times 2 plus 3t, and since they have asked for the point where it intersects y-axis, so on y-axis x is 0, and from the question we know x is ln 2 plus 3t, and this, if this is equals to 0, and we know ln 1 is all 0, otherwise it cannot be 0 anywhere else. So it means the input, that is 2 plus 3t, has to be 1, means t equals minus 1 over 3. That's why we now we got y is t over 2 minus 3 times t, 2 plus 3t, so it is t over 2 plus this, we got again y also, minus 1 over 3. So now we got a point on the line, point on the tangent, that is x and y, 0 comma minus 1 by 3, and we can calculate the gradient. Here we have t dy over dx in terms of t, so we got 2 over 3 into t, y, after substituting t value as minus 1 by 3 we got this. So gradient is 2 by 3, so equation of the tangent we got y minus y1, that is minus 1 by 3, equals gradient times x minus x1. So finally we got y equals 2 over 3x minus 1 by 3, or we could have written it as 3y equals 2x minus 1. For 7th question, the diagram shows the curve y equals tan inverse x over root x and its maximum point m where x is 0. First part is show that A satisfies the equation A equals tan of 2a over 1 plus a square. So from this question we have one condition given. The condition is at x equals a, we have the maximum point. So for the maximum point, the derivative of the function has to be 0. So at m, we will find the dy over dx and make it equals to 0. So from here, dy over dx means the quotient rule. So denominator square, denominator as it is, into the differentiation of tan inverse x, that is 1 over 1 plus x square, minus numerator, and the differentiation of root x is 1 over 2 times root x. We can directly write it here. So in the numerator, we can take 2 root x into 1 plus x square common. So we got here as 2 times root x square. We can, it's type, we take the cross multiplication, or sorry, we can take the LCM, and then we got 1 plus x square into tan inverse x upon x. So we can take these all thing as the denominator, and since it is 0, so denominator can never be 0. It means numerator, which is 2x minus 1 plus x square tan inverse x, is 0. So from here, if we solve, tan inverse x become 2x over 1 plus x square by taking this thing here. Since it is tan inverse, so from here we can get x as tan of the other hand side, right hand side, that is 2x over 1 plus x square. Now at m, x was a, so we can say that a satisfies this equation. A equals tan of 2a over 1 plus a square. For the b part, verify by calculation that a lies between 1.3 and 1.5. Since from a part we have seen a satisfies this equation, a equals tan of 2a over 1 plus a square. So whenever we need to find whether the root lies between two given value, we use the sign change rule. For that, we need to make first one function. So I make it as fa equals tan of 2a over 1 plus x a square minus a. I have sent this a to the other side, or we can take this tan of this whole thing to the left hand side also to make another function, but that's fine. Now we have to just substitute a value as 1.3 and 1.5, and we will see what is the value, and our mode of the calculator has to be radian. So from here we can see this is going to be positive 0.1484, tan f of 1.5 is negative 0.1783. So by sign change rule we can say that a lies between 1.3 and 1.5. C part, use an iterative formula based on the equation in part A to determine a correct to 2 decimal places. And it says that give the result of each iteration to 4 decimal places. So from the first and second part, we have seen that a equals tan of 2a over 1 plus a square has the root between 1.3 and 1.5. So we can make an iterative formula based on this, that is a n plus 1 is tan of a n over 1 plus a n square. So we can take first iteration by ourselves. We can take a value anywhere between this. So I have taken 1.4. Now we will put this value in the calculator as answer, means 1.4, and then press equal key. Then we will get answer as 1.4. So that when then we will get another iteration by just putting tan of 2 into answer over 1 plus answer square. In the calculator, we will put this, and in place of 1.4, we are going to use answer. We will get directly 1.3864. Since they have asked to write the iteration 4 decimal places, so we are not going to correct it. Whatever we see till 4 decimal places, we'll write here. So again, by just pressing equal key, we'll get the third iteration 1.3951, fourth iteration 1.3895, fifth iteration 1.3931. And from here, if we see the pattern, or we can see we got the answer correct to 2 decimal places, it is going to be 1.39, and that is correct to 2 decimal places. For 8th question, with respect to the origin O, the points A and B have position vectors given by OA as 1, 2, 1, OB as 3, 1, minus 2. The line L has equation R equals 2, 3, 1 plus lambda times 1 minus 2, 1. And first part is find the acute angle between the direction of AB and L. So we can say AB, we have, let's say, A here, B here, and O somewhere here, and we can see that this is OA and this is OB. So this is the direction of AB. This is the vector AB, and let's say the line is somewhere here, and since we have this direction vector of the line 1 minus 2 1, so we can take this as the direction vector. So we need to find this acute angle. So what we are going to do is going to be first of all we'll find AB, and this of course we have from the line. So AB, we can get AB is B minus A. So 1 minus 2 minus 1 2 1, we got 2 minus 1 minus 3, and direction of L is 1 minus 2 1. From here we can see. So we need to find the acute angle between them. So we can consider this as A, the AB, this angle, this vector as A and this vector as B. So all we need to find is, by using the cos rule here, modulus magnitude of vector A is going to be for this square sum of their square, and then we got root 14. Magnitude of vector B is going to be root 6. A dot B is just multiply by component wise and then add them together. We get 2 plus 2 minus 3, that is 1. And finally we have the formula cos theta as A dot B over magnitude of A into magnitude of B. So theta become cos inverse of this whole thing. Cos A dot B was 1, and magnitude of A into magnitude of B was 14 into 6, that is 1.46, the last from the calculator, and that too it is in the radians. So the acute angle between AB and L is 1.46 till 3 decimal places. B part, find the position vector of the point P on L such that AP equals BP. So L is somewhere here. Let's say there is a point P. This is point P, and A is somewhere here and B is somewhere here. We need to find these points so that AP distance and BP distance, they are same. So what we are going to do, first of all we will consider the AOP, because OP lies on L. This is vector, this is the line L. So, and we have the direction, we have the equation, vector equation of line L. So we can say in general OP would be of this type: 2 plus lambda times 1, 3 minus lambda times 2, and 1 plus lambda times 1, that is 2 plus lambda, 3 minus 2 lambda, 1 plus lambda. So from here we will calculate AP. AP is B minus A. So that's it. We got this. These are the components of AP. And similarly we will calculate BP, because why we are doing it, because we know that condition is AP equals BP. So we calculated AP and we calculated BP just by using the simple rule that AP is going to be vector P minus position vector of P minus position vector of A, and BP is position vector of P minus position vector of B. And then we will calculate AP distance, just that is the magnitude of the vector AP, and BP distance again. So we will get this in terms of lambda, and now we are going to equate them because that's the condition. So if we equate AP equals BP and then we square it, so we can get this square root con, and then 1 plus lambda square, 1 minus 2 lambda square, and lambda square equals this whole thing. Then we open it, we can see this is going to be first bracket, this is going to be second bracket, and this was lambda square. Similarly, this is the first bracket we open, this is the second bracket, and this is the third bracket. And there are 1 2 and 4 6 lambda square here, and 1 4 5 1 6 6 lambda square here. So lambda square got cancelled everywhere. So finally we got, if we simplify, we got 2 minus 2 lambda from this side and 14 minus 4 lambda from the right hand side. So altogether when we cancel, we calculate this, 2 lambda, 4 by lambda minus 2 lambda become 12, that is lambda equals 6. So once we got lambda, position vector of P, that is OP, we have already calculated. We only need to substitute the value of lambda. So we got 8 minus 9 and 7. And that's the position vector of Here's the question number 9. The equation of the curve y equals x to the power minus 2 by 3 ln x for x greater than 0. The curve has one stationary point. Find the exact coordinates of the stationary point. So it has only one stationary point. First of all, if it is stationary point, we need to calculate dy over dx and make it equals to 0. And there are two functions, so of course we are going to use the product rule to find dy over dx. First function as it is, differentiation of second function, that is 1 over x. Second function as it is, and differentiation of first function is minus 2 by 3 down, and x to the power minus 2 by 3 minus 1, that is minus 5 by 3, making it equals to 0. We got x to the power minus 5 by 3 minus 2 by 3, x to the power minus 5 by 3 ln x equals 0. Since x is greater than 0, so we cannot say that it is going to be 0. Altogether, we got then 1 minus 2 by 3 ln x equals 0, which gives us ln x equals 3 by 2. So if ln x equals 3 by 2, so from here directly we got x as e to the power 3 by 2. Once we got x value, since they have asked for the coordinates of the stationary point, we will calculate y value as well. And y is simply substituting the value of x here. That is e to the power 3 by 2 to the power minus 2 by 3 and ln e to the power 3 by 2. And here ln e to the power 3 by 2 would be directly 3 by 2 because ln e to the power x is directly x. And here we solve it, it is e to the power minus 1. So altogether 3 by 2 e. So y become 3 by 2 e. So the stationary point is coordinates e to the power 3 by 2 and 3 over 2y. 3 over 2e. And here for the b part, show that integration from 1 to 8 y dx is 18 ln 2 minus 9. So from the first part we have seen y is x to the power minus 2 by 3 ln x. So we have two functions here, e to the x to the power minus 2 over 3 and ln x, and we are going to use ILATE because we are going to use the integration by part. From the ILATE we can see ln x comes first, ILATE, so ln come first and algebra come second. So first function will take as u as ln x, and the second function will take dv over dx as x to the power 2 minus 2 over 3. So from the first one we will calculate dv over du over dx, that is 1 by x, and from here we will find v by integrating the function, and we got 1 over 3 x to the power 1 by 3, that is 3 times e to the power 1 by 3. And then we will use the formula integration by part. The integration become first function into second function and integration of differentiation of first function into the second function dx. So we can cancel this. From the first part we have seen it is 3x to the power 1 by 3 ln x, and here it is x to the power minus 2 by 3. We need to do the integration. So it would be x to the power minus 2 by 3 plus 1, that is 1 by 3 upon 1 by 3. So we multiply by 3 here. And integration, the limits are 1 to 8. So we will substitute the limits. 3 into upper limit 8 to the power 1 by 3 ln 8 minus 9 upper limit to the power 1 by 3. We substitute here everything. Minus the lower limit is 1, 3, 1 to the power 1 by 3 ln 1, 9, 1 power 1 by 3. So we can see 8 to the power 1 by 2 is 2, ln 8 is ln 2 cube, 9 into again 8 to the power 1 by 3 is 2, and this is 0, ln 1 is 0, and 9 into 1 is that is 9. So we can see it is 3 2s are 6, and into 3 will give us 18. So 6 into 3s, 6 3s are 18 into ln 2 minus 9, because there are minus 18 plus 9, that is minus 9, and that's what we need to prove. So we have proved that this integration is 18 ln 2 minus 9. 10th question, that is the last question. The variables x and t satisfy the differential equation dx over dt equals x square 1 plus 2x. When x is 1 and x is 1 when t is 0, using partial fractions solve the differential equation obtaining an expression for t in terms of x. So there are three things. First one is using partial fraction. Second thing is solve the differential equation and again obtain an expression for t in terms of x. These three things we have to do. So let's, of course, we have to start from the partial fraction. For that, we have to see that how to write it. So x terms together, splitting the variable separable, we say. So dx over x square into 1 plus dx, 1 plus 2x, and dt goes the another side, we got dt. Integration we apply, and now we will do the partial fraction here. 1 over x square plus 1 x square into 1 plus 2x. So we can write a over x plus b over x square plus c over 1 plus 2x. We multiply the whole thing by x square into 1 plus 2x everywhere. We got left hand side as 1, and a times x into 1 plus 2x, b times 1 plus 2x, and c times x square. So since it is true for all the values of a, b, and c, all the values of x, so we can substitute any value as it suits. So first of all, we will put this x value as 0. So this got vanished, this got vanished. We got b, and b into 1 plus 0, that is 1. So b equals 1, and x equals minus 1 by 2. When we put x equals minus 1 by 2, this first term got vanished, second term got vanished, and third term is x square, that is 1 by 2 square is 1 by 4 times c. So c is 1 and into 4, that is c equals 4. At x equals 1, and then this become 1 into 1 plus 2, 3a plus 3 plus 4. So we got 3a plus 7. So 7 goes there, that is minus 6. 3a equals minus 6, a equals minus 2. So we will substitute these values of a, b, c here. We got this as minus 2 over x dx plus 1 over x square dx plus 4 over 1 plus 2x dx equals dt. We substituted here and we combine these two. Now we need to solve the differential equation. So minus 2 by x is minus 2 ln x, minus 1 over x square, integration is minus 1 over x, and then 4 over 1 plus 2x is 4 times ln 1 plus 2x, and divide by the differentiation of this 1 plus 2x, that is 2. So we can cancel. Dt integration is t and plus constant of integration. So first condition, at x equals 1, t is 0, or we can say when t is 0, x is 1. So we substitute here, we get minus 2 ln 1 minus 1 plus 2 ln 1 plus 2 equals 0 plus c. So we got ln 1 is 0, so only minus 1, 2 ln 3 equals c. So we got c value as minus 1 plus 2 ln 3. So we'll substitute here, that is minus 2 ln x minus 1 upon x plus 2 ln 1 plus 2x, t minus 1 plus 2 ln 3. Now we can see t is at only one place, so we are going to rearrange this. So t become 2 times, we have 2 here, here, here. So 2 times 1 plus ln 1 plus 2x minus ln x minus ln 3, and minus 1 over x, and this one goes there, that is plus 1. So we can combine these ln things together by using their properties. So there is a minus minus, so in the division we multiply 3 and x, and 1 plus 2x in the numerator. So t become 2 ln 1 plus 2x minus 1 by x plus 1. So that's the final step, and that was the final question, last question of this paper. So I hope it was of some help. So let's meet again in the next video with another past paper solution. Till then, thank you so much.